The table below shows the value v of an investment after n years. We want to use the calculator to determine the exponential regression equation that models the data. We want to round a to 2 decimal places, where a will be the initial amount or initial value, and round b to 3 decimal places, where b is the base, and because we have exponential growth, b is called the growth factor. So for the first step, we'll enter the data into the calculator. So we'll press Stat and then Enter. Notice how there's some old data in L1, so if we press left and then up, we can press Clear and Enter to clear the entire column. And now we'll enter the new data. So we press 0, Enter, 3, Enter, 7, Enter, and so on. And now we'll enter V of n in L2. We'll press the right arrow and enter V of n. Now that we have the data in the calculator, we can perform exponential regression. To do this, we'll press the Stat key, right arrow to calculate. We want exponential regression, which is EXP-REG, toward the bottom. Option 0, so we press Enter and Enter again. To 2 decimal places, A would be 2509.16. To 3 decimal places, B would be 1.079. So the exponential regression model is 2509.13 times 1.079 raised to the power of n. We do have to use the variable n here because v is a function of n. Now, based upon the regression model, what is the percent increase per year? We can determine the increase per year by looking at the base, or the growth factor, where b is equal to 1 plus r, where r is the growth rate, or in this case, the percent increase per year. Notice our base is 1.079, which would be equal to 1 plus 0.079, which means the percent increase as a decimal would be this value here. Expressed as a percentage, this would be 7.9%. To convert the decimal to a percentage, we multiply by 100 and add a percent sign, or move the decimal point to the right 2 places. So this would be 7.9%. Next, we're asked to find v of 13 and round to 2 decimal places. To find v of 13, we substitute 13 for n into our function, which we see here. So we can enter the right side into the calculator, but because we have to graph this function later, I'm going to go ahead and enter the model into y1 and use y1 to find this function value. So I'm going to go ahead and press y equals. I've already typed in the exponential function here. Notice how we're using x here instead of n. But now because we have the function in y1, we can go back to the home screen by pressing second mode for quit. And now we can enter y1 of 13 to find the value of v of 13. To do this, we press the vars key, right arrow to y vars, enter. y1 is already selected, so we press enter again, and then in parentheses 13. To 2 decimal places, this would be 6,742.29. Which means the value of the investment after 13 years is $6,742.19. So it's important that we do enter years here and dollars here. The next question is, how long will it take for the value of this investment to reach $12,000? In other words, what would n be when v of n is equal to 12,000? To form the equation we want to solve, we substitute 12,000 for v of n as we see here. We're going to solve this graphically, and since we already have the right side in y1, we're going to enter 12,000 in y2, and then find the point of intersection to find the value of n. So we'll go back to the calculator, press y equals, press enter to go to y2 and enter 12,000. Now I do have to adjust the window to make sure we can see the point of intersection. To save some time, I've already done that. So if I press window, you may want to change your window to look like this. The X scale and Y scale are optional. This is how often you'd have a tick mark on the X and Y axis. Let's go ahead and press graph. So the X coordinate of this point of intersection here would be the value of n, where the function value is 12,000. To find this point of intersection, we press second trace for calculate, option 5 for intersection. Because we only have two graphs on the coordinate plane, we can simply press enter 3 times. Enter, enter, enter. We're asked to round to 2 decimal places, so n would be approximately 20.58. Which means in 20.58 years, the value of the investment will reach $12,000. We have one last question. We're asked to determine how long it will take for the value of the investment to double, again round to 2 decimal places. And for consistency, we'll use the initial value from the model that we found, not from the table of values. So looking at this equation here on the right, the initial value from the model was 2,509.16. So to find when the investment will double, we want to find the value of n, where the function value would be twice the initial amount, which would be 2,509.16 times 2, or 5,018.32. And again, to solve this graphically, we already have this in y1, so we'll now enter 5,018.32 in y sub 2, or y2, and again find the point of intersection. So we'll go back to the calculator one more time, press y equals, and we'll change the 12,000 in y2 to the doubling amount of 5,018.32. Again, if we use the initial value from the table, this amount would be slightly different. So now we'll press graph. There's the exponential model, and here's y equals 5,018.32. Our goal is to find the x-coordinate of this point of intersection, so we'll press second trace for calculate, option 5, and then enter 3 times. Enter, enter, enter. To 2 decimal places, this will be approximately 9.12. Which means in 9.12 years, the value of the investment will double. I hope you found this helpful.